Hi guys, so in today's video I'll be showing you how to solve problems by using a substitution, and I'm going to do a problem for an indefinite integral and a definite integral because you have slightly different steps. So let's say we have the integral of 2x times e to the power of x squared. This can't be solved as a common function since it's a product, but we can use a substitution. Now, generally what we do is use a u substitution. What we have, this is with respect to dx. What we have to do is get rid of all these x variables and turn them into a different variable. So in this case, we're going to be turning them into u. So the first step is to look into this integral and find out if we differentiate something, is the derivative of that also in this integral. So if we use, for example, x squared as our u value, let's differentiate that. We get 2x. Now there's already a 2x in the integral, which means they can cancel out, so this is the right substitution to use. So let's write this again. We have 2x times e, now it's to the power of u, and if we rearrange this, we get du over 2x. Now these two cancel, and all we're left with is u variables, which is what we want. So now we can go about solving it. So e to the power of u du, that's simply e to the power of u plus the constant of integration, and then we just fill in the u value, which was x squared plus c. So that's how we solve this problem for an indefinite integral, and now I'll show you how to do a definite integral. So let's suppose we have the same integral, 2x times e to the power of x squared dx, but now we have limits, so let's make them the lower limit 1 and the upper limit 2. So first of all, we go about solving it the same way. So we pick our u value, which was x squared. The derivative of that is 2x. Oh, sorry, that's now a u value. And then we rearrange this to make du over 2x. And we are left with this definite integral. Now, because we've changed the variable, we now have to change the limits. So we do this by putting the x's in this u value as the current limits. So what happens if we make x 1 is the lower limit, well then u equals 1 squared if we plug the 1 into this x. So that is simply 1. So the lower limit stays the same. How about if we use the upper limit 2? Well, then u equals 2 squared, which equals 4. So the new upper limit is now 4. And we can rewrite this now as the integral from 1 to 4, e to the power of u du. And now we can go about solving it the normal way. So if the integral of e to the power of u is just simply eu, and since it's a definite integral, we do this, we don't have the constant of integration, and then we simply put these values into the u value. So it'll be e to the power of 4 minus e to the power of 1. And that's the answer. So for a definite integral, all you have to do is change the limits, but the procedure is the same. And in my next video, I'll be doing more of the similar problems.